The James Webb Space Telescope had to be very cold. The telescope, the mirror itself, had to be cooled down significantly, and the camera, especially the mid-infrared camera behind it, had to be cooled even more. If I can go into absolute temperature units, room temperature is up here at about
Mm,
300 Kelvin. Water freezes at 273 Kelvin. Dry ice is down at about 195 Kelvin, and that's about as
okay.
cold as most people have ever experienced. That you're not supposed to even touch dry ice because it is very,
Right.
very. Liquid air is down at about 80 Kelvin, good nitrogen 77.
Okay.
Helium, the lightest common element, is down at 4
Mm.
Kelvin. The mid-infrared instrument on Webb, I believe, is operating at about 6 Kelvin, so a little bit above that.
Has anything at that level flown?
So we
Or were
have
you
had,
still
yes, we have had that fly in instrumentation that has been developed most recently for combined Japan and NASA missions with
mm,
names of various kinds, but they were X-ray missions, and
okay.
many of them had a lot of challenges in the
Mm,
technologies, but the refrigerators worked.
okay. Vastly oversimplify and butcher how these sensors work. My understanding is that there is a voltage output from these materials in response to certain wavelengths coming in. And if you don't keep them cold enough, then the incoming wavelength is lost in the noise. Is that a fifth grade level explanation or am I way off?
That's a pretty reasonable explanation. I could give
Okay.
you a little bit more since you wanted to do
Please.
the rabbit hole thing.
Yeah, yeah.
Many detectors, not all, but many detectors of light work in a way that is broadly similar to the way the camera in your cell phone works.